is going to bind them. And already we had some discussion of like this, no? You know, moment of inertia, bring the ideas of that. This is the x-axis, this y-axis, this that axis. I think we made some conditions, no? Or let it be x. And what is the assumption? R very much less than x. And this molecule will have speed along x, along y, and also along z. It will also spinning about x, about y, and also about z. Then can it move along x? Can it move along y? Can it move along z? As here. So therefore, how many degrees of freedom due to translative motion? 3 degrees of freedom. Degree of freedom, I'll use symbol like this. So 3. It can possess energy by moving along x, by moving along y, by moving along z. So 3 degrees of freedom. Degree of freedom, we represent symbol f, small f. Okay, the symbol. No, it can rotate about x, y, z. But what is moment of inertia about x-axis? What you can write 2 into 2 by 5 mr square, no? R very much negligible, Ix will be 0. What about moment of inertia about y or z axis? This should be equal to how much it is? Parallax's theorem, 2 into 2 by 5 mr square plus m into x square. Agree this? About say y-axis, first due to about its center of mass, 2 by 5 mr square. At what distance it is? At a distance of mr square. Mx square. X is the distance from center to center. This is from origin to the center. Okay, now you say that r very much less than x, but x is not negligible, no? So therefore, what will happen to moment of inertia about y and z axis will be non-zero. So what will happen to kinetic energy about y and z axis will be non-zero. So therefore, it will have 2 degrees of freedom due to rotational motion, 3 degrees of freedom due to transitive motion. But sir, like it's having angular velocity, though having angular velocity, but what is the rotational kinetic energy about x? Moment of inertia itself is 0. So what do you expect the rotational kinetic energy will be 0, no? When omega is when moment of inertia is very small, then rotational kinetic, how you define of I omega square. When I is 0, then what is rotational kinetic will be 0. So 3 degrees of freedom due to translatory, 2 degrees of freedom due to rotative. So how many degrees of freedom are there? So therefore 3 plus 2. So diatomic gas molecule, how many degrees of freedom it will have? 5 degrees of freedom. Then what all energy it will have? Half of it, so like due to translational, rotational. Okay, now due to translative motion, how much it will be? 3 kT by 2. Due to rotational motion, due to rotation, half kT plus half kT. How much it will be? KT. What is the average kinetic energy of diatomic gas molecule? Shall we write 5 by 2 kT? How much translational? 3 by 2 kT. Rotational, it will be average rotational kinetic energy, kT. Average translational kinetic energy, 3 by 2 kT. Then how you have to divide, how you have to distribute? Here, kT by 2. Due to translational kT by 2, due to rotational kT by 2, due to translational kT by 2, due to rotational kT by 2. Add up all this, 5 by 2 kT. Means now I increase temperature. What will happen? RMS speed will increase and root mean square angular velocity also will increase of this molecule. Diatomic gas molecule. Next we'll go for, sir, we are not understanding the degree of freedom. That's the best question what you can ask for teacher. Okay, sir, everything is fine, but still we are not at all understanding degree of freedom. Okay, let's take best example. You are throwing a ball vertically up. I'll going to generalize degree of freedom. Let me throw a ball vertically up with a velocity, say v1. It will ascend and it will come to certain height, no? Instantaneous. Again, it will fall back. Will you agree this? Now it is constrained to move only along y-axis. So how many degrees of freedom? In what all possible forms it can possess energy, kinetic energy and potential energy. So how many degrees of freedom if a ball is projected vertically up? I'll say 2 degree of freedom. If you take viscosity also, then due to viscous drag, what will happen to the body? Heat will be generated. It can also absorb heat. Then due to heat absorption, what happen? It's undergo deformation. So then what is another additional energy it can possess? The thermal energy. Will I agree this? So therefore, how many degrees of freedom if you take viscosity? 3 degrees of freedom. If you take only the kinetic energy and gravitational potential energy, 2 degrees of freedom. Agreed? If you take even the viscous drag, heat will be generated and that heat will be absorbed by the ball itself. Let's assume. So therefore, then what happens? 3 degrees of freedom will come. Okay, let's do one thing. If you take a door, how many degrees of freedom it will have? So now here, ball projected vertically up will have 3 degrees of freedom. Why 3 degrees of freedom? So what all energy? Energy can be in the form of kinetic energy, gravitational potential energy, plus also what? Heat generated, ms delta t. So 3 degrees, 3 different ways it will possess energy. So 3 degrees of freedom. Getting the idea? Okay, now if I project a ball at an angle, now it will move in a parabolic path. What all? It can move along x, along y, gravitational potential energy, and also let's say that viscous drag. How many degrees of freedom? Anybody?
4.
4 degrees of freedom, no? Temperature will increase T2, this is T1. So number of degrees of freedom. This is a way number of degrees of freedom. You have to learn like this, huh? Degree of freedom, just remember definition. What is use of that? Hmm? Okay, let's take the door. It will be, usually it will be on the ground, no? Let it be some door or something, you know. How many degrees of freedom? Anybody? It can rotate only above the axis, no? Or above the inch. All of you in your house, you have seen door. Okay, no, door what can it move up, down? Nothing, no, it can only rotate. It can only rotate about y-axis. So one rotational kinetic energy. Then it is at a height, gravitational potential energy 2. Then it can undergo deformation, elastic potential energy 3. If it's a metal door, it can also, if temperature can increase or decrease, so thermal energy. So based on the degrees of freedom will come. So there's a door will be usually wood, no? So let's not bring the temperature. Wooden door. So how many degrees of freedom? Number of degrees of freedom. So this should be equal to how much? 3. 1 due to rotational kinetic energy. Next, again, the another one is gravitational potential energy. Then another one is, I'll write all the things. Y2. Then elastic potential energy. UE, I'll write it.
Sir,
Center of,
what about Z?
huh?
Viscous drugs.
What happened?
Sir, air drag.
Viscous drag is there. Okay, viscous drag, what will happen? As the wooden door will not absorb heat, no?
Okay.
Okay, you do have many things. Okay, what about fan? Let's take fan. Fan will be at height, no? Anybody? Fan. Number of degrees of freedom. Gravitational potential G. Rotational kinetic energy about axis. And fan is made up of metal, no? And definitely it will go and eat up, no? Am I right? And it can also oval. Okay, let's neglect oval. So one, rotational kinetic energy, gravitational potential, 2. Then as it rotates, air drag will act, heat will be generated. So 3 degrees of freedom has come. Then also we know elasticity. It will expand, no? Centrifugal force. So there'll be also elastic potential energy. So what all we have, the total energy will be number of degrees of freedom. There's energy here, total energy. So degrees of freedom are 3. Okay, now total energy we'll see there. What all mgh plus iy omega square. Then viscous drag. Okay, energy due to viscous drag. Shall I write here? Okay, that is nothing but heat generated. ms delta t, and also elastic potential energy. So how many degrees of freedom it is having? 4 degrees of freedom.